Welcome to this exciting and expository lecture on polygons. In this lecture, I'm going to show you how to get the formula for calculating the sum of the interior angles of a polygon as well as the sum of the exterior angles of a polygon. Now, when you understand how to calculate when you understand how the formulas are gotten, it won't be difficult for you to play with questions that are brought out from the concept of polygons. Diverse questions could be coined out from the concept of polygons, and you'll be asked to resolve them just like word problems. But a proper understanding of how these formulas are deduced will help you in tackling these questions. So let's begin with the interior angles of a polygon. And before I talk about that, I want to define a polygon. A polygon is simply a two-dimensional closed figure. I said a two-dimensional closed figure. What do I mean by that? Two-dimensional meaning that you can draw it on a plane sheet. It's a plane shape. And I said closed figure, meaning that all the sides meet with each other at some point. All the sides meet with each other at some point. And so the polygon is a two-dimensional closed figure having straight sides. Now, you will never find a polygon having a curved side. That is no longer a polygon. Yes, it's a plane shape, but it's not a polygon. So a polygon is a two-dimensional shape that has straight sides, closed shape having straight sides. All right, good. Now let's go over to the interior angles of a polygon. First of all, what do we mean by interior angle? Interior angle simply means the angle that is formed inside the polygon by a combination of two lines. Now you see, in the polygon we have over here, let's label the sides as 1, 2, and 3. Now, when side 1 and side 2 meets, an angle is formed, and that is an internal angle. Also, when side 1 and 3 meet, an angle is formed. That also is an internal angle. Good. When side 2 and 3 meet, an angle is also formed, and that is also an internal angle. Yes, and that's how it happens for all polygons. Good. Now, how do we find out the sum of the internal angles of a polygon? To do that, we have to understand that the least or the smallest polygon we have is a triangle. When I mean the smallest, I mean the polygon with the least number of sides. The least number of sides is a triangle. Why? That's because you can never have two lines to form a closed shape. Two lines can't form a closed shape unless one of them is curved. And when one of them is curved, we no longer have a polygon. So, to have a polygon as a combination of straight lines, then we can only have that with three lines coming together, not two. Therefore, polygons start from three sides, which is a triangle. Now, since the polygon with the least number of sides is a triangle, let's now find out what is the total sum, or what is the sum of the angles, the interior angles of a triangle. We know that to be 180 degrees. Yes, the sum of the total interior angles of a triangle is always 180 degrees. For that reason, anytime we are given a polygon, we will divide the polygon into triangles. Yes, because whatever number of triangles we find in that polygon, we will simply multiply it by 180. Yes, that means we'll be having 180 times the number of triangles we have in the polygon. Yes, and that will be equivalent to the total interior angles of the polygon. Let's do it so that you can understand better. Now, we are given a quadrilateral. A quadrilateral is a four-sided polygon. Dividing this quadrilateral into triangles, we will pick a point or a meeting point, actually a meeting point where two lines meet inside of this quadrilateral, and we connect it to other meeting points in the same polygon, which is the quadrilateral, without forming a curve. Yes, without forming a curve. So we are going to pick this point. So with that point, let's draw a straight line to the other end. Yes, and we have formed a triangle at this side and another one at this side. Now there is no other way to draw another straight line from this same point to any other corner without forming a curve, right? You can take a careful look at it by yourself and you see it so. Therefore, we can only divide this quadrilateral into two triangles. So the total angle, the sum of the interior angles of this quadrilateral is therefore two triangles multiplied by the total sum of the angles in a triangle, and that gives 360 degrees. Now, this is the reason why we are told that the sum of the interior angles of a quadrilateral always equals 360 degrees. We can do this for other polygons. For example, the pentagon. A pentagon is a polygon with 5 sides. Doing the same thing, let's connect one end or one point of this pentagon, one vertex, one meeting point where two lines meet is called a vertex. Let's connect one vertex internally to other vertices inside the same pentagon, and let's see how many triangles will come out of it. Now let me quickly draw another pentagon over here so that we can make use of 2 points and see if we have the same number of triangles. So starting with this point, we have one connection, we have two. Those are the only lines which can be drawn without forming a curve. Okay, now let's make use of the top vertex and see. We're having one, we're having two. Yes, those are the only ways to draw the lines without having to form a curve, right? So in both cases, we're having one triangle, two triangles, three triangles. 1, 2, 3. That means a pentagon can be divided into 3 triangles. Therefore, the sum of the interior angles of a pentagon will be 180, which is triangle times 3, and that will result to 540 degrees. Good, but hold on for a while and let's take a look at it. At the end of this, what did we discover? Pentagon having what? 5 sides. But how many triangles did we find in the pentagon? We found 3. Alright. Quadrilateral having 4 sides. But how many triangles do we find inside of it? We found 2. That means there is always a shortage of 2. 4 minus 2 giving us 2. 5 minus 3 giving us 2. Do you understand? Yes. Quadrilateral having 4, the number of triangles became 2. A pentagon having 5, the number of triangles became 3. Now, how much did we remove from 4 that gave us 2? We removed 2. How much did we remove from 5 that gave us 3? We also removed 2. That means if the number of sides of the polygon is referred to as n, we can always remove 2 from n. Yes. And when we do that, that will give us the value which become ready to be multiplied by 180, right? So we can multiply n minus 2 by 180, and this gives us the expression for the sum of the interior angles of a polygon. So we can say that the sum of interior angles, that is the symbol for angle, the sum of the interior angles, we are talking about polygon here, is given by n minus 2 multiplied by 180. Alright, now what if we want to look for just one of the angles? Now you must remember that all the sides of the polygons are straight if it's a regular polygon, and also the number of sides must be equal to the number of angles if it's a regular polygon. Therefore, if the number of sides is equal to the number of angles, being a regular polygon, we can also divide whatsoever value we have gotten here, we can divide it by n, the number of sides, and that will give us the value of one interior angle. So one interior angle will be n minus 2 multiplied by 180 divided by n. N is the number of sides, of the polygon. So that is the expression for the sum of the interior angles of a polygon, as well as the value of one of the interior angles of a polygon. With this, you can always find out the value of the interior angles of a polygon. Maybe you were given the sum in the question, you can find out the value of one interior angle, or if you were given the number of sides, you can also find out the sum of all interior angles of that polygon. Now, moving over to the exterior angles. What is an exterior angle? An exterior angle is simply the angle formed by the sides of a polygon when extended, when extended beyond the vertex. So here is an exterior angle, here is an exterior angle, as well as this. Those are exterior angles. And check it out, we have how many in a triangle? In a triangle, we have 1, 2, and 3 exterior angles, just as we have 1, 2, and 3 interior angles. That means the number of interior angles is also equal to the number of exterior angles. This also means that whenever we can have the total exterior angles, that is the sum of all the exterior angles, we can also divide it by n, because n is the number of sides which is also equal to the number of angles. Yes, n is the number of angles. Yes, and n is also equal to the number of sides. So if we are told that the number of sides is 5, it's a bonus for you to know the number of interior angles. So you can divide the sum by that number to get the value of 1. That was what we did above. Alright, now what is the value of the total exterior angles of a polygon? Now look here. Let's call this angle theta, and let's call this theta 1, and let's call this theta 2. Now you see that theta 1 and theta 2 sum up to give what? 180 degrees. And why? That's because theta 1 and theta 2 are both on a straight line, and angles on a straight line sum up to give 180. Therefore, I can say theta 2 is equal to 180 minus theta 1. Good. And remember that theta 2 is our exterior angle, while theta 1 is our interior angle. And also remember that we found that previously that the value of one interior angle, which is this, is equal to n minus 2 multiplied by 180 divided by n. You see this? Good. Therefore, theta 2 is 180 minus this. Right. Good. Now, remember, we are not looking for just one of the exterior angles. We are talking about the sum, meaning all of them combined together. And I say that all the exterior angles, that is the total number, is also equal to the total number of interior angles, which is also equal to the total number of sides of the polygon. So, for example, if we are talking about a pentagon, which is a polygon with 5 sides, it means we have 5 exterior angles, and this value is the value for just one of those exterior angles. So, if we are to get the sum, what do you think we will do? We will simply multiply this by what? By 5. Good. Now, let's assume we don't know the number of sides, so we are just assuming it's n. So what do? We will rather multiply this by what? By n. Good. So the sum of the exterior angles will be 180 minus n minus 2 multiplied by 180 divided by n. Now it's good you put this in a bracket because you are subtracting the answer of this from 180 and not just individually. Good. And all of this will be multiplied by what? N. Now this is not really big as you may think. We just have to resolve it gradually. And how do we do that? Let's start from brackets using broad mass. Brackets, the innermost bracket. Okay. Now, from the innermost bracket, we'll resolve this. So, opening the brackets above, that is this, we are going to have 180n, because 180 will multiply n to give us 180n. Then 180 times minus 2 gives us minus 360. Below we are having n. We have resolved that. Now remember, on the left hand side we are still having 180 minus, and we are still going to keep this in a bracket. Before, we are now having the bigger bracket which we had previously, and we multiplied it by n. Good. So now we are going to open the big bracket. Doing that, n we multiply 180, and that will give us 180n. Again, n we multiply this. Remember, it's not just this but minus this because of this minus sign. So we'll be having minus 180 n times minus 360 all over n times n. This is another way of writing the multiplication, saying 180n minus 360 over n in a bracket being multiplied by n. This is another way of writing it. Yes, just like this. All right, so eventually see that this will cancel out this, and actually it should still remain in its bracket because signs are very important when doing mathematics. So it's better for us to still keep it in its bracket. Though we are removing the big bracket, we are removing this bracket, the big one, but this small bracket should still be there. It's still conserving what we have in the bracket, waiting for us to first of all resolve it completely before we now subtract it from 180n, which is waiting outside there. Hope that's clear. All right, good. Now what we have in the brackets will now be 180n minus 360 in the bracket, and out of the bracket, out of the bracket we'll be having 180n minus this. Good. Here now we ought to resolve whatever is in this bracket to a single number before we subtract it from what is outside of the bracket. That is the very reason we kept it enclosed in a bracket securely until we got to this point. But at this point we can't still subtract because there is an unknown attached to one of the numbers. So what do? Now we finally open up the bracket. And how do we open up the bracket? We do that by recognizing the fact that there is a 1 here, minus 1. There is a minus 1 standing here. So we can multiply whatever we have in the bracket by that minus 1. And that will give us, over here, we still having 180n. Minus 1 times this gives us minus 180n. And minus 1 times this gives us, minus times minus gives us plus, and 1 times 360 gives us 360. Good. So eventually this is what we're having, and 180n subtracted from this, that's cancelled out itself, and what we are left with is what? 360. Good. Remember that what we're actually solving for is the sum of the exterior angles, sum of all the exterior angles, and that has given us a value of what? 360. Yes, we also said that if we know the value of all this, of the sum of all the angles, exterior angles, when we divide it by n, which is equal to the number of sides or the number of interior angles or the number of exterior angles. I am mentioning the three of them because they are all related. So whichever one you are giving your question, just know that yes, that is also the number of exterior angles. If you are given that the number of interior angles is 5, then you know that is also the number of exterior angles. So to get one of the exterior angles, you will simply divide 360 by what? By n, as we have established earlier. Good. Therefore, the value of one exterior angle, yes, the value of one exterior angle, the value of one exterior angle is 360 divided by n. Good. So with these two formulas which we have just deduced, you can go ahead to solve the diverse questions that are drawn out from the concept of polygons. Hope you enjoyed the lecture. If you did, please subscribe to this channel and also tell your friends about it by sharing the video. Then make sure you like the video and also click on the bell icon so that you can get notifications when other videos are uploaded. This is Thanks for watching. God bless you, and remember that Jesus loves you.